Now let's see the different protocols that is used for the communication between two nodes. How we are communicating, how two sensors or how two nodes of IoT devices can communicate with each other. What are the different protocols that we use and why we use. So we have different protocols. Most of the modern smart devices and sensors can connect to low power wireless network. Low power wireless network. We know what is a low power wireless network. If you want to communicate with each other, you will use a Bluetooth. So Bluetooth is very low power communication media by which you can transmit your data. Other thing will be if then you say why not WhatsApp or why not any mail, I can send the data with mail. So it will again come with the different phenomena. It will again come the TCP/IP protocol comes into the picture. Those 5 layers will come and your data will be transmitted all those with the help of those 5 layers. Okay. But if we want to do one-to-one communication, what I told you, MAC protocols, which are responsible for one-to-one communication. So if I'll not go to up to 5 layers, if I'll go only up to 2 layers, means physical layer and data link layer. And data link layer is responsible for one-to-one communication. If I do like this, so in the MAC layer, we have these protocols, which is responsible for one-to-one communication, right? So there are different protocols like Wi-Fi, you know, by which we can do one-to-one communication. Zigbee, there are a very low power, for the low power devices we use Zigbee protocol. So Wi-Fi is, have you heard about IEEE standards? IEEE 802 standard, sorry, IEEE 802 standard. This particular standard is the standard for the computer networks. Okay? And you will know in this particular project, IEEE 802 project, different technology has come and they have given different standard to those technology. So Wi-Fi has 802.11 and in that also we have some flavors like A, B, C. 802.11A, 802.11B. So if you communicate your mobile or you connect your mobile with the access point, so you are using 802.11 protocol to communicate. And 802.11 again it will come in the layer of MAC layer protocol. Which layer protocol? Media access control layer protocol. Now the second is Zigbee. So Zigbee is another technology which is responsible for low power devices. For the low rate communication. Let's say I don't want to have a high rate communication. Let's say I don't want to send my pictures or my video. I just have to send some text data. So for that, this Zigbee technology is very much useful. Okay? And by this Zigbee technology has been used by many devices. Like your access point and your mobile is there, which is using Wi-Fi technology. In the same way, there are different devices which use Zigbee technology. Okay, and the Zigbee standard is 802.11. Sorry, 802.15.4. 802.15.4. So it is a latest technology that has been come out. Wi-Fi was 802.11. There are 1, 2, 1, 3, and then 1, 4 came. So 1 and then 1, 5. So 802.15.4 is the standard for Zigbee type of technology. Means the protocol for the low power devices. Are you getting it? What do you mean by low power devices? Which doesn't have much power to do processing. So that is called low power devices, like sensor nodes. Those are low power devices. Okay.
Sir, all these use the unlicensed spectrum only or the licensed ones?
Which one?
So all these protocols use the unlicensed spectrum?
Yes. Then we have Z-Wave. Z-Wave is another low power responsible for low power device communication. We have LoRa. LoRa is another technology which is come up with the LoRa sensors. We have another set of sensors which is called LoRa sensor, which is using this low power, low rate and this type of technology called the LoRa. So LoRa, when they are using, that is called low rate something when there is a wide area network. So they are making with the low rate communication and they are making it wide. So that type of technology has been come up. Here Bluetooth, we already know how the Bluetooth will work. That is again so if it has been asked that which is a low power communication, so you know which is low power communication. So nowadays what we use Bluetooth, which is a low power communication medium by which we can send the data from one device to another device. Development of low power, low cost wireless transmission devices are promising in the area of IoT due to its long battery life and efficiency. So why it is necessary? Why we cannot use Wi-Fi all the time? The reason is battery life. Because those sensors, wherever we put those sensors should have more life. So to increase the life, we should have these type of technology which is using less power. Because for a sensor node, the maximum power goes on transmission and reception. So the maximum power for transmission, then second highest for the reception of any signal, then you can see there is a different modes of this. So like a human have different modes, you will be either in the sleep mode, active mode, right? What are the other modes you have? Human being have different modes. What are those? I told you one, active mode and sleep mode. There is another mode. There is another mode. What is that? What is that? Idle mode. So sometime in the classroom you become idle. So in the idle mode, devices, they are not communicating. They are not receiving anything, they are not sending anything. So in the same way, human being will do. If you are in an idle mode, you cannot hear anything. Means you are hearing, but you cannot actually hearing anything. So you are hearing, but you are not listening, right? So there are different things, hearing and listening. So if you are in an idle mode, so you, in the same way, when a devices will be in idle mode, it is not receiving, not sending anything. It is just sensing the environment. For that, it will take less power. Getting it? So there are three type of modes mainly: active mode, sleep mode, and idle mode. So in an idle mode, nodes are not receiving, not sending, so they are consuming very less energy. Sleep mode, no energy transmission, right? So there is no transmission, no reception, as well as no sensing. Sleep mode. And then there is an active mode. So active mode has two things: either you are communicating anything or you are receiving anything. Getting it? In the same way, devices will also have these three modes. So all these three modes are very much necessary for those low power devices. So we have to control that very less number of transmission should be there, very less number of reception should be there. So you have to make sure that when you are sending the data, it should have with the low power technologies like this. So we have in the latest era, we are using 6-LoWPAN. 6-LoWPAN, which is again 6 is for IPv6 standard. Low, which is again for the low rate or low power. Low power wireless PAN. PAN is personal area network. PAN is for the personal area network. when I am making a personal area network to take all those IoT devices, and I am using a technology, so that is called 6LoWPAN, which is working in IPv6. Do you know what is IPv6 and what is IPv4? Do you have any knowledge about it?
IPv6 64 with encryption and IPv4 with
Anyone? First of all, what is IP version 4 and version 6? Could you tell me what about IPv4? Anyone? Anyone? No one knows about it? किसी को तो पता होगा? I think. So, do you know this thing that every computing devices should have two addresses? How many addresses? Two addresses. One is called physical address, another is called logical address. Okay? What is physical address? At the time of manufacturing, they have given an identity. So that is called its physical address. That is never going to change. Then there is another type of address which is called logical address. Logical address used to change when we are connected to the internet. So for the internet connection means if your device is connected with the internet, you should have IP address, which is called Internet Protocol Address. Getting it? Now, this IPv4 version 4 address has some limitation. That is of 32 bit. How many bit? 32 bits. So with the help of 32 bits, how many computing device we can individually give the address? Could you tell me? 2 to the power of 32. How much it is? 2 to the power of 32? Some billion trillion devices have given unique addresses. Why we need unique addresses is, if we are in the internet, we should have unique addresses. Right? Why it is necessary? It is necessary because we are using TCP/IP protocol. And in a TCP/IP protocol, in the network layer, we use IP address. For the MAC communication or the media access communication, we do not use IP addresses. We use physical address for the media access control. But when we are going to the network layer, so we use IP addresses, and this IP address is very much necessary when you are connecting your device to the internet. And when we are talking about IoT, it is all about internet. Okay, so one devices, if they want to connect with the internet, that should have IP address. Got it? Now I told you what is IPv4. Now in 2012, IPv4 addresses has been exhausted. Do you know that? Do you know that? Then another type of addressing system came, that is called IPv6. With the help of IPv6, and what is the bit size of IPv6? Do you know? 128 bit. So with the help of 128 bit, we identify a device. Getting it? With the help of 32 bit, we were identifying previously with the help of IPv4. Nowadays we are using IPv6. So in my laptop, we have IPv4 addresses.